All right, now it is. Okay.
Who was it recording last time?
I don't know. There was one time I forgot to switch to the right channel, so the entire class was like a silent movie.
Well, that's real useful.
You should edit it and put those black boxes with the words for what they're supposed to be saying. Like an old film style.
Yeah, well, like a screen like a whole screen of words, every, 10 seconds or so, something like that.
But you need to have that really crappy piano music in the background.
Yeah, Charlie Chaplin, right? Okay, so let's go ahead and get started. The first thing I want to show you guys is something that you might have seen already, because some people have the email, already set up, so you might have gotten this part already. This is the grade distribution of this class. It is not sorted by alphabetical order. In other words, people with last names starting with A's do not necessarily do well in this class, because that would be kind of funny if it is also sorted in alphabetical order based on last name. So after the adjustments, sorry?
Is it sorted by student ID number?
No.
Those B's and C's
should be a
should
very
be
strange
yellow.
correlation if it is sorted by student ID number.
You really need to make those B's and C's yellow. You really need to make those B's and C's yellow.
Well, most people only care whether they're getting a C or not, so that's why. Okay, so we have 6 people getting A's, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. About 10 people getting B's, and then we have the C's here. I would say that's about 10 too, maybe 11. So we have 6, 10, and 11 for A, B's, and C's. The D's are here, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 D's. The F's are over-exaggerated, because I think there are 2 or 3 F's, that really, should not be showing up here, because they're not exactly people who took the test, okay? More than grade actually matters in that case. So the F's would be 1, 2, 3, 4, 5, 6, 7, 8, about 8 F's, which is a very strange distribution if you think about it, okay? We have 6, and then we have 10, and then we have 11. So the 10 and the 11 are still, the mode, basically the majority of the class. In other words, if I have to say the majority, it's going to be somewhere between a B and a C. Okay, a high C, a low B, whether, whichever way you want to look at it. And then we have, about, the same number of D's and the same number of F's. Basically, not really doing very well in this test. Okay, so that's the grade distribution. I stretched out the spectrum so that we actually have a number of people getting A's. The stretch is 1.5 times the original score. It is better. It's more than what I agreed to on that day, because on that day I kind of said, okay, we'll consider one of the questions as extra credit. That would have been a 1.33 multiplier. This is the result of a 1.5 multiplier, which is more than 1.33. Okay, so that's basically how it stands as a whole class. Are there any questions about this? Yep.
Where can we see our grades?
Your own grade, you can see it in your grade link. If you click your grade link, you can see your own grade. I aggregated all the exam 1, Q1, Q2, and Q3, and Q4. They're all under the same category called exam 1. So when you look at it, you can look at the individual score. You can also look at the composite score for exam 1 as a whole. Yep.
How did you add each questions the percentage?
How
did you add the each question the percentage?
All questions have the same weight. They all have the same weight. They all have 10 points. So the overall score of the test is 40 points, but but when you look at the percent, I only report it as percentage. You can see that these are all percentages already, and that's basically what you see. When you see 100%, that means you have 40 points for the 4 questions.
Okay.
No, I take it back. That means this is after adjustment. This is after a 1.5 multiplier.
Okay, when we have 150 percent, how many points we got on the question? 15 points out of 10.
Sorry, say that again.
Yeah, on one question I have 150.
That means you have one. That means you get the original full score already, and that's why after the 1.5 multiplier you get 150%.
Okay.
Yep. Okay. Any other questions? Yep.
Getting confused. It's a only midterm, only exam that we have, and then the final, right?
Sorry, say that again.
Okay. This is only one exam that we have, and then the next exam will be the final.
No, there's one more exam before the final. This is exam 1, there's exam 2, which is also 20% of your final grade, and then there's the final exam, which is 40% of your final grade. All the homework added together will be 20% too. So when you look at your grade, you can also look at your grade based on all the work that I have graded. I know I have not been grading a lot of homework assignments, so that's why you can also get your grade based on all the work that I have also graded. So that would be kind of like an average score. It's not really accurate at this point because we only have about 40% out of 100% of the scores determined at this point. I would say less than 40%. In other words, there should be another 60-something, close to 70% of points to be made, from here to the end of the semester.
Cool.
So that means, if someone gets a flat 0 in exam number 1, that person can still easily get a B out of this class.
Oh, okay.
Question? Oh, that was it? Okay. Remember what I said on day 1? What I said on day 1 was, someone can not turn in any homework assignment, flunk all the tests except for the final exam, ace the final exam. The 40% of the final exam is more than enough for someone to get a C. Because a C is 37.5%. But I also said that the likelihood of something like that to happen is also pretty low. Because the concepts keep stacking upon each other, and that's why it is really important for you guys to read the material before the class so that you understand, what I will be talking about, and then after the class, go to the lab and actually practice those things. Now, I know that some people have not been reading because I can tell, Moodle keeps track of everything, and I found a few people who have not even touched the first few links, like, how to add numbers, the add instructions, stuff like that, or memory operands, versus the other operands. So there were a few people who have not even clicked on those links. And I would imagine either those people already know this stuff, okay, there's no need to click on the link, or, well, I don't know,
PDF file. The link on PDF file. Click only one to get everything.
No, that's not true. It is not true because I have extended my collection of notes. There are some stuff here that is new, that is not a part of the quote-unquote book. Yep.
Would you mind uploading an updated PDF file so that we can download that one file again and have the up-to-date
Because
stuff?
I've been out the whole.
But that's not the whole thing. I mean, you should click on each link separately, just so that you know that you have everything covered. Yep.
Have you anybody just took the final passed the class? I mean, done? I think passed.
I have not kept track of that sort of thing, so.
So there's been no.
The answer is I do not know. There's no. I have not analyzed, all the scores of, from past semesters to see if anyone have passed the class just because of the final exam. I would say the chance is pretty slim. Not impossible, just slim.
Somebody should try.
Hmm?
I say somebody should try.
Well, but we're not even close to that yet, and yet we have 20% from the second exam, we have 40% coming from the final exam. So that's 60% already. And then we have a lot more homework to come, which is going to be another 10% or so. So we still have 70% of the score undetermined at this point. Okay? So that's basically where we stand at this point in terms of points. Now let me show you something. I'm not sure. Well, since it has nothing to do with scores, I think I can do this without actually getting into trouble. Okay. This is what Moodle can do. Okay, it can do reports, and when I look at reports, there's a whole bunch of stuff that I can do. One thing is based on participation. Okay, so I can generate a participation report. I can choose whatever module that I want to look at. Let's say we pick something that we should have clicked several times already, such as let's see here, addressing modes and memory allocation. Okay, which is something that we should have read some time ago, and I can then select look back how many days, look back 2 months, which is the beginning of this class. Show only students, and show all the actions, and then we can make it go. And I can just kind of hide the names of students, and I can sort by all actions. Okay, in other words, how many people have, how many times have someone clicked on it. Okay, and this is what I can see. I can see that some people have not clicked on that link at all. Yep.
Oh, never mind. I was going to say, can you
It's
show
no-
us what the
you're
ones that
not
no
one
ones
of
have
them.
clicked on?
Yeah, you are not one of them. And then there are 2 people who clicked on that link exactly once. Okay, and I think once is going to be, unless that person printed out the first time, once is not going to be enough. I mean, just reading that stuff once is not enough. And you can also, I can show all, students at the same time. You can see how, the distribution of the links or the number of clicks. You can see some people have clicked it up to, 37 times. Now, that does not always guarantee a high score, but, when you compare the mean, which I think would be around, 6 and 7, versus, people who have clicked it like once or twice. Yep.
Can you show a correlation between students and the number of times they've clicked links and
This is
their
it.
grade?
No, there's no correlation to the grade yet.
You
I
say
can
you
work on
can't
that.
show that?
No, I cannot show it because there's no tool to do it just yet. I can make my own query to do it.
Yeah, let's make a graph.
Make a graph. Yeah.
A
later
Venn
on.
diagram.
But I think this is indicative of something. Okay, this is indicative of something. There's no guarantee. Okay. There's no guarantee that someone who clicks it, say, 37 times is going to do well in a test. Okay, that's not a guarantee. But at the same time, for people not to have reviewed the materials enough times, that's also, that's a red flag to me. Okay, it's telling me that something may not be right here. Yep.
Can you give us a list of files that no one's yet reviewed at all?
I can do something kind of like this. Okay, let me see. If I can go back using just the keyboard
Alt
commands.
back.
Alt backspace.
No, Alt back arrow.
Oh,
Or is it Control Alt?
no, Control.
No, it's
Backspace.
Alt
Shift.
back arrow.
Hmm?
You can move it down.
Or I can do it like this, right?
Yes.
Oh, that's you. I can do it. I can click. I can click the back button now. What is it? Okay, it's still showing. Okay, so now we are back to this screen here. Now there are other reports that I can see too, which are kind of interesting too. This is an activity report which does not show students, but it does show how many views I have each particular thing has have. Now some of the hidden stuff, obviously there will be 0 links or 0 clicks, so I can actually tell how many people have say downloaded the files that the sample files that we do in the class. And take at least downloaded the files. People who have downloaded the file does not mean they have studied or used those files, but it's kind of at least show that there have been 18 clicks to the files that are uploaded for the day of the 8th. Okay, so I can see all this stuff here which is not exactly whether people really study or or not, but it's some interesting data. Yep.
But are there any that have no clicks yet? That are available?
That are available?
Yes.
Well, there are stuff down there that are probably nobody has or very few have clicked.
Scroll up, scroll up, scroll up, scroll up.
But everybody has clicked. Everybody. Okay, every link has been clicked by somebody.
I saw one. Go up a tick.
It's probably a hidden one.
Count spaces.
That's a homework that I just made up today. So unless you click it on the phone, when it
Refresh it.
Okay. So you can see how I can see stuff. I don't do this, to individual students. I really do not. Okay, I don't really just look at one student and say, okay, let me see whether this student has clicked this link, and clicked that link, and let me take a look at his score for the test. I have not done anything like that. It's way too labor intensive, and I really do not want to look at all that data. I just look at everything kind of in general, and look at the spread of the number of clicks. So it seems like 6 to 7 clicks is kind of like the norm or the mean, the number of, in terms of number of clicks. So when there's only like 1 or 0 clicks, that's kind of a red flag in my mind, saying, hey, this person even has not clicked on this link once. Now it is possible that let's say I'm buddy with Tommy, okay, and Tommy has a super fast printer and he wants to print out everything. And I can always tell Tommy, hey, when you click on a link and print out something, make a copy for me. Okay, so that's entirely possible that I don't even need to click on any link at all myself. Okay, that's entirely possible. It's just that in general, if you look at the distribution, it is unlikely that more than so many people should be not even clicking something once. Yep.
You said the PDF notes were out of date.
Okay, so let's go take a look at that one. Okay, so that's why there are 2 versions of a lot of the links. They are not incompatible. It's just that one is an updated version of the other. So the material is presented in a slightly different way, but they are still related to the same topic. I can give you a few examples here. In fact, I can take a look at something that we will be talking about today. Okay, so when you look at this part here, okay, I'll just open this one in a tab and open the other one also in a tab. Okay, OS calls in assembly language. I think it's this one here. Okay, this is the old style. This is the old style. I can tell because this is chapter 9 of quote unquote a book. Okay, which is really kind of old. Okay, so let's minimize this one, and then the other one is new because this is a module. So if you see module blah blah blah, that's the new stuff. Okay, if you see it is a part of quote unquote a book, that's the old stuff. They're not incompatible. They still talk about the same thing. It's just that the explanation of the concepts have changed a little bit because I found out the old way of presenting it may not be the best way, but I still leave the links up there just in case people want to read both versions. So are there any questions about the links? No questions? Okay. And a few people have asked me, how to study for the test or how to study for this class in general. One thing is do not trust me. Okay, just don't trust me if I say something. You write your own mini program to verify that concept. That I cannot overemphasize that particular concept. Because that really is how I would study for a class like this is to write miniature programs for each and every concept that I learned in this class. Okay, well maybe not each and every, for each big topic I would write a mini program to test my understanding of the topic. Because tech can make mistakes, tech can lie, but GDB cannot. Okay. Well, I guess since I gave you the version of GDB, I suppose I could have changed the source code and make GDB lie as well. But that's too much work for me too, so I would not do something like that. But that's how you can approach the topics of this class is really to test it. When we talk about the base scaled indexed addressing mode, the operand, write a simple program. Okay. Initialize some dot data portion. Go figure out a particular random operand that should get to a particular location according to your calculations. Okay, and then run the program and see whether that really happens or not. Okay, it can be as simple as that. Okay, so are there any questions at this point about or comments of any kind? Yep.
The practice exam seemed a little easy compared to certain things on the test. And I'm just, maybe show us some of the curveballs on the practice exam and not the test, or also on the test, but it seemed it was a higher level of difficulty, so if you thought you were prepared by doing just the practice exam, you may have been surprised.
The practice exam, is supposed to show you the format of the questions, but not necessarily the difficulty, or it will show you the scope of the test, what kind of instructions will be involved, but it does not necessarily show you the difficulty level because I cannot really assess the difficulty level either. So to me, I would just look at the practice exam question, and then I would think, okay, what is another way to ask a question on a similar topic, and that's basically how I come up with the actual questions in the actual exam. Usually about 24 hours before the test. Yep.
A good example would be you had 3 problems that you gave us for the one where we had for each of them. Why not just make 4 of them that are all identical and give us one of the 4 and not give us the other 3 as our example? You created 3 example problems. Or
for
3
the
problems
test.
for each test.
Yes.
3 problems of each type. Question 1 had 1, 2, or A, B, and C, right? So why not create A, B, C, and D that are all the same, and then you give us all the D's or all the A's or all the B's or all the C's for the example.
It doesn't make a B or C until 24 hours before the test.
Exactly.
But make the test sooner.
I have yet to invent the time machine, so if I had the time machine, I will probably not be teaching here because I will probably look into the future, the stock market in the future, and it won't be I can do some other things. Okay, well, let's take a look at the new homework assignment. We are moving on the topic onto topic number 6, and I will go back to Max 3 and show you how I would approach that problem too. The new homework assignment is count spaces. Okay, that's basically what we are going to do this time. Create a new folder called spaces in your home folder. Okay, the mkdir would do it. Write the program in this folder. The logic of the program is as follows in pseudocode. So this is not exactly C. This is kind of like pseudo C. You first initialize a counter to 0, and then you have a do-while loop. The do-while loop will first try to read a character from standard in into a character variable ch. Okay, we'll talk about how to do that because at this time we don't know how to do exactly that. And then the second thing is if a character was actually read, then you want to check something else. If the character is the space character, then go ahead and increment the counter by 1. Okay? And you want to keep doing this as long as a character was actually read by this line of the program. That's the logic of the code that you have to implement. Yep.
What do you mean by a space character?
ASCII code 32. Okay, ASCII code 32 is the space character. What?
Why not \W?
What?
Why not \W?
Or you can just
regular
close
expression?
space code, will do the same thing. Okay, but 32 is the ASCII code of the space character. And then in order for my script to test the program, you have to follow these rules. The source code has to be, the source file has to be named spaces.s. The count variable has to be a 32-bit unsigned integer with the name count. The program must read from standard in or cin. How many people do not know what I'm talking about here? Either standard in or cin. They're basically the same concept. Okay, that's the default input file of every program written in C or C++. Standard in is the terminology for C, and cin is the terminology for C++. You guys didn't talk about that when you took 360? They should have covered this, in CISP 360. It's okay. We'll talk about this too in this class. So, but having an understanding of standard in will definitely be helpful. Yep.
So you have to flush out the standard in before.
Nope, you don't have to flush out anything because we are talking to the operating system directly. So there's no need to flush anything. The program must terminate properly at end of file. In other words, it cannot be stuck in an infinite loop. The program must be in the folder spaces. Immediately after the loop, place a label check here so that my script knows when your part is done, so I can check the actual number of spaces against what you report in your program as the number of spaces. The resulting count of spaces must be stored in a 32-bit unsigned integer that is allocated from memory at the label named count, which is a really long way to say count:\int 0. Okay. If you keep the count in the register, my script cannot find it. Okay, so you can keep the counter inside the register when your code runs, but by the time you get to the label called check here, it has to be copied back into memory so that my script knows where to look for it and check the value. And and then the program must exit properly with an exit code of 0. So we'll talk about that also. What is the exit code and how do we exit the program properly? When you're all done, create an archive using this command here. Okay, this time I use this font here so that it's kind of clear where the spaces are. Upload the archive file to the upload interface below, which is down here if you are a student. I cannot see it because I'm not a student. Okay, so any questions? Go ahead.
Is there a way to create that unsigned?
Create that unsigned?
Or make the account unsigned?
Well, when you allocate, bytes in, the dot data segment, you can only say, how many bytes you want to allocate and the bit pattern that you want it to be initialized to. But remember, there's no type associated until you actually perform calculations. Okay, so when the only time you have to worry about whether something is signed or unsigned is when you use conditional branches after a compare. That's the only time when whether a number should be signed or not makes any sense. Because otherwise, add is the same whether or not it is signed. The way you allocate is the same whether it is signed or not. The way you subtract is still the same whether it is signed or not. Okay, so the only time when you actually have to be sign sensitive is when you have to do a jump if below versus jump if less than. Though that's the only time you have to be sign sensitive. In this case, there's no such places because we are not doing any compare with count. Count is really just a counter, and adding one to count is sign insensitive. Okay. Are there any other questions about the description of your homework assignment? Yep.
Are we going to get a good way to test this ourselves?
I think so. Yep. So let's go ahead and take a look at this program. What you can do is to create specific files, and in those files you specifically put in a number of spaces from 0 spaces to test your program to make sure that it can when there are no spaces it does not count anything, to 1 space per line, 2 spaces or whatever. Then you can use the redirect symbol to use the same test file for your program every single time. Okay. I will talk about that too, how to redirect from a file so you can test your program more easily. Okay. So first thing first, let's go back to the previous homework assignment, and I'll show you, how I would do that homework assignment. Previous homework assignment is called max3. It is supposed to find a maximum of 3 variables. And this is the file that you want to download. And I'm going to extract it to today's folder. So this way, everything will be logged, for today's class. Go to that folder. Today is 2011-03-17. Okay, here's the program, and it obviously is not the solution. Okay, this is just a sample, and I put some instructions here, just to show you where you're supposed to put your instructions.
Can you put it in the middle?
Make it bigger.
Oh, make it bigger? That good?
Yeah.
Okay. Okay, so the first thing I would do is I will copy and paste or move the comment into the area where I'm supposed to implement the program. So I would start with line 1 to line 9, and then I will copy to the area where I'm supposed to put the code here. So I would say line 1 to line 9. Either move or copy, it doesn't matter which one. I'll just do a copy to the current line. And now we have the same code copied. Did you guys catch how I specify the current line?
No.
It's consistent with the assembler, isn't it? The dot means here. Okay. Okay, so I'm going to write my program here. The first thing I want to do is to compare x and y, and then I want to see, do you guys want me to show you, like really step by step, or do you want me to just give you the solution?
Step by step solution.
Step by step?
Let's get the solution first, and then you can go back over step by step anything people don't understand.
No, step
Okay.
by step. Step by step.
Okay, I can do the step by step once, okay, and then the next one I just do it like that. Okay, so if you want to do this step by step, the first thing you want to do is to translate this to something else. Okay, so this is the first translation. The first translation is to test for the negation of this and branch around the then portion. Okay, if you follow everything mechanically, that's how you do it. So you want to convert this and say if not x is greater than or equal to y, and x is greater than or equal to z, go to, or we'll use label L1 here. And the label L1 is the else part here, so I will put the L1 over here. That's the first part of the translation. Then the second part of the translation is to take a look at this thing here and say, how do we get rid of the not? Okay. Now, fortunately, in this case, I can use De Morgan's law. How many people know what is De Morgan's law? Okay, De Morgan's law is a really nifty trick to take out the negation and the conjunction and turn it into a disjunction. In other words, I can preserve the meaning of this thing here without actually having to go through the mechanical translation. Okay, and that involves turning the negation and say this is x is less than y, or x is less than z. Okay, it's a simplification, but does it make sense? Are these two, are the conditions of line 28 and the condition of line 29, are they the same?
Yes.
It is not the case that x is greater than or equal to y and x is greater than or equal to z. Isn't that the same thing as saying that x is less than y or x is less than z? They are the same. Okay? So that means I have just saved myself a few steps of the blind conversion process. Because converting a disjunction is fairly easy. If I want to convert the disjunction, I can do it like this. If x is less than y, go to L1 already. Right? Because with a disjunction, if at least one condition is true, the whole thing is true. Okay? If x is less than y is not true, we have a second chance. If x is less than z, I can go to L1 as well. Because I have two reasons to go to L1. The first one is when x is less than y. The second one is when x is less than z. Are we doing okay so far with this? Okay. So that means, at this point I can stop the translation because I have simple comparisons and, a simple go-to. So at this point I can stop the seed or the high-level language, conversion, and now I can actually start converting into assembly language. Okay, the first one is I have to do something like this. Now, ideally speaking, it would be nice if I can just do a compare. So I would just do a compare first. Okay, in comments, I would say compare y to x. Okay, compare x to y because remember the order is reversed. Okay. And I would say jump if and only if x is less than y. And since it is unsigned, I have to use JB to label L1. Now, ideally speaking, this is what I want to do, but I cannot do it. Why can't I do something like this? There are two reasons why I cannot do it. One,
You have two memory operands.
I got two memory operands. That's the first one, and the assembler will catch that one. What is the second reason?
Type mismatch. One of them is an int, one of them is a word.
Exactly. The width of these two operands are not the same. Y is a dot word, which means it is a 16-bit number, and x is a dot int, which means it is a 32-bit number. Okay? There are quite a few ways to take care of this. Okay? I would not shoot for the simplest way. I would just shoot for the most direct way to do it. Okay? So the first thing I would do is I would move x into a register, move LX into, say, EAX. And I don't need to comment this because this is the actual code at this point. And then the second thing I want to do is to do something like this, but I can't really do it, just the way it is right now. Now, the assembler won't complain, but the width is not going to be right. Because, if I did it like this, it would have picked up Z as if it is a part of Y, and the comparison would not work correctly. Okay? So before I do something like this, I have to say move $0 into EBX first, so that I initialize EBX to all zeros. And then I can just move W into BX, so that the least significant 16-bit of EBX is what I want to compare. So this is not the only trick, but this is one of the more direct trick to convert a 16-bit number into a 32-bit number. It works really well with unsigned numbers. It does not work for signed numbers, and that's why I make sure that all of these numbers are unsigned. Yep.
What would JL do for that if you used it? If you put it unsigned, is it just going to interpret it incorrectly?
Only when you cross over to 8, 0, 0, 0, 0, and then a whole bunch of zeros. When you cross over, the JL will trigger when it is not supposed to. Okay. As long as you use 0 to 2 billion, it will still work properly. But once you get to 2 to the power of 31, then it will work incorrectly, because the signed interpretation will say it is less than, but it's actually not. Okay, so now that I have everything in EAX and EBX, now it does not hurt to write some comments next to this, and I can say EBX is Y, and over here I can remind myself and say EAX is X. Okay, so at this point I just need you to compare a register to a register to replicate what I want to do on line 31. So I would say compare long. Remember to use the long, even though it's not required. It is always a good idea to spell out the width of the operation. And we want to compare, the first one is EBX, which is Y, and the second one is X, which is in EAX. And I can just use the JB instruction, because that part is completely okay. There's no problem with that instruction itself. Are we doing okay so far with the translation process? I'm not done yet, okay, because I still have the other one here. I would do something that is bad, okay, because I'm going to copy and paste. Okay, 1, 2, 3, 4, 5 lines. So I'm just going to copy and paste. Now, when you copy and paste, you have to remember to change, something here so that it is going to do what it is supposed to do. Yep.
Is EBXY or BXY?
Sorry?
Is EBXY or is BXY? At the top.
At the top?
Yes.
Which line?
Where you commented EBX is Y.
EBX is Y.
Lines 35 and 41, BX is Y.
Is it BX or EBX?
EBX.
EBX.
Is both BX and EBX, because EBX is the signed extended version of BX. Okay, with unsigned numbers, all you have to do is to pad it with zeros. With signed numbers, it is a little bit harder, because it depends on the most significant bit in 16-bit mode. If it is a 1, then you have to pad it with 1s. If it is a 0, you have to pad it with 0s. And that's why I make sure that we use only unsigned numbers, so it is much easier to do the sign extension. We do okay? Okay. So now we are down to here, which means I want to move X into max. Okay, well that can be done pretty easily because X is already in EAX. So I can just say move L, EAX into max, which is allocated in memory up there somewhere. Okay. Max is already a .int, so that's not a problem. We can do that. Okay. Any questions at this point? Now, before the else, I have to remember to do one thing, because I have to remember to get out of the entire conditional statement. So I would have to do a JMP, and in this case, since I use L1 to handle the outer conditional statement, I would use L1 underscore exit to represent the exit point of the outer conditional statement. So this way I can maintain, what is in the inner conditional statement and what is on the outside conditional statement. But this is just a trick that I decide to use. You can use other ways to handle this part. Now, whenever I define jump to a label, I would immediately define the label itself and make sure that I exit all the way up to here. Because if I don't do that, if I do not define the label right away after the jump instruction, at this point I would have forgotten, okay? And the assembler will complain and say, oh, you have not defined L1 underscore exit, but to me, I would have forgotten the meaning of that label, and then it will be harder for me to remember exactly where that label is supposed to go. So that's why when I write programs, I don't really write it sequentially. I jump around a lot, okay? Because I program by the structure of the logic, not using the linear line-by-line type of programming. Okay. So are we doing okay so far? Yep. Okay. So once I can handle this part, the other part is pretty much the same thing, okay? Because it is. If you look at the structure here, the inner conditional statement, it looks almost exactly like the outer conditional statement, except I don't want to use L1 anymore. I want to use another label name, or another family of label names, so that I don't accidentally use the wrong one. Okay. So in this case, because I already know how to take care of the other one, so now I can just copy and paste a whole bunch of stuff, which also means it can be dangerous, because if I do something like this and I forget to change one of the label names, then it won't work correctly. And then the sign extension part is also a little bit different this time, because this is still comparing X and Y, so the sign extension will still be the same. Okay. But in this case, I can keep the same thing here in EAX and EBX, being one being X and the other one being Y. But when I compare, it is probably a better idea to reverse the comparison, so that I'll be comparing Y to X instead of comparing X to Y. And then the JV instruction will work exactly the same way, okay? Because the order of the comparison is now preserved. As for the other one, I want to keep Y, so I just have to change the way I define X. So, yep.
You still want to go to L1?
Very good. In this case, I want to go to L2, which is over here. Very good.
Line 59. 59.
59. Oh, the other L1. And then, okay. So we are okay with this. I just have to fix the other one, because I need to compare Z and Y in this case. So if I want EAX to be Z, I have to do the same trick again. I have to move L$0 to EAX first, because Z is also a 16-bit number, so I have to use the sign extension trick one more time. Okay. Are there any questions about this part? This is good? Okay. So if I do not branch to L2, because of both of those reasons, I can just move Y into max. Y is already loaded into which register? EBX. Okay. So I can say move L EBX to max. Okay. The last part here, okay, I have to remember to do one thing, because I have to remember to get out of the conditional statement. So in this case, I will jump to L2 underscore exit, which is actually redundant, because L2 underscore exit will be here. So effectively, it is exactly the same as L1 underscore exit. But I will still do it like this, because just in case I have some other logic after the inner conditional statement before the end, I can do so without having to change my labels. Extra labels don't cost you anything. The assembler will assemble just as quickly without, so it doesn't cost you anything, even though I have two labels that are defining the same location in memory.
Actually, you have three labels defining the same location in memory.
Yep, and also text checks the result here. Yep. Question? Okay. So I just have one more thing to do, which is, how do I copy Z to max? Now here I have to be a little bit more careful, because I have two reasons to go here. The first reason to go here is on line 54, which means Z is not in any register yet. The other reason is to use the line 60 to go to L2, in which case Z is already loaded into EAX. But since I don't know which reason got me onto line 67, it's probably better just to do it all over again. Okay, it is not wrong, it's just burning up some extra cycles. So that's okay. So what we need to do here is the same trick. Move 0 into, say, EAX, move word, Z into AX, move L, EAX into max, and that's it.
Or we can use like ECX at the beginning for Z.
You can do that too. You can preload, XYZ into registers EAX, EBX, and ECX, but then you have to remember which one is which one. It works too. That works too. Okay, so that's the end of this code. Okay. Are there any questions? Does it work? Yep.
Did you want us to duplicate the structure of the if-then exactly?
No, you do not have to duplicate the structure. I'm just doing it, because if someone is only reading my notes in order to understand how to do the conversion, this would have been the way to do it. Yep.
So we can just duplicate the results?
You have to duplicate the result. Yep. If you have a simpler way to implement the same logic, hey, be my guest. That's fine too. Which is the question that you asked, when we had the assignment assigned.
I was smart enough to ask it before it was due.
Yes. Okay, so I think the program is going to work, but we can double check.
Smart money's on assembler error.
Sometimes it's better if it doesn't work, because then I can show you, how I would debug a program. Some of you may be better debuggers than I am, but at least I can show you what I will go through in order to debug a program. Okay, so here's the program. And I would put a breakpoint on line 25, just as my script would. And then I will run the program up to that point, and then I'll change, XYZ at this point so that we can actually test whether it works or not. The most difficult case, if someone's program did not handle the greater than or the greater than or equal to properly, it will break when two numbers are the maximum and yet they are the same. Okay, that's when things will get broken. Yep.
Is there a convenient way in GDB to force a value into a register?
Into a register? Yes. Yeah. It's a $EAX equals something. If you use that, that would change EAX to a particular value. But nobody asked me before, so that's why I have not talked about it.
And you haven't put that in your notes. Why?
Because it never occurred to me it would be important.
I think that should occur to you right now.
Okay.
Let's pause this.
I need to make a wiki activity so that you guys can add to the notes.
That's not a bad idea. MediaWiki is pretty easy to set up. It's a bit bloated, but very simple, and almost everyone uses it.
Okay, so we'll go ahead and change a few things here. Oh, that won't work, will it?
No, you just completely borked memory.
That's okay. Well, I just blew a part of max, the max variable, which is okay because it will be set anyway later on.
When did you set max? Oh, you set max.
Yeah, because that's Z and max is after Z, so I just blew the most significant 16-bit of max, which at this point should be considered uninitialized anyway. So let's say X is 32, and then we say set word Y is also 32, because this is actually one of the trickier cases. If you make all three numbers different, it's actually less complicated. You won't catch some of the problems, when you set two of the numbers the same way. So and then we'll set word Z to be smaller one, so we'll make it like 16, and then we put a breakpoint at my other checkpoint. Checks result here, and then continue the execution. And then at this point, I will take a look at maximum, and that can be done using just print max, and it is 32. So as far as this test case is concerned, the program worked correctly. It doesn't mean the program is correct. It just means that it works for this particular test case. Okay. For those of you who have taken, cisp310, from the past, you will also have to use pre and post conditions to make sure that the entire program works all the time.
Will we ever have to do that? Because the test, if you give us a test on it, it'll be about 2 hours long.
I'm just kidding. But it comes in handy to understand that your program will work for all possible values of X, Y, and Z. That's the reason why we talked about the pre and post conditions in cisp310. Okay, so are there any questions about this particular example? No? Okay. Any questions about the steps that I took in order to write the program? No? Most of you probably bypass a lot of the steps that I took. Yeah?
Yeah.
But mechanical methods are good. Mechanical methods are good because it is reproducible, and once you know that the approach works, it will always work. Okay, so now we are back, to here, and we'll particularly talk about interrupts and system calls. Yeah, we skip something, so that you can get started with your homework assignment. And I would skip this one also. Okay, I would skip this one to get to the one that you will need for the homework assignment, and then we'll come back and talk about that one, so that you can get started with the homework first. Okay, it's this one. Let me double check. I think it is this one. Okay, this is a relatively short module. All it does is to talk about the stuff that we need to know to get the homework assignment done, and you can see how the time, the date, kind of matches today's date, because it is synchronized.
Did you change it today? Oh no, that's never mind. Sorry.
It's automatically generated by the program that creates the HTML document.
That's 5 days from now.
No, it's a year ago.
It's 5 days from now, a year ago.
Okay.
Yes.
368. So
So we are fairly close. Since I changed the order of the topic, this is actually about appropriate. Okay. So the other thing I want to do is to show you what I mean by a system call table. Okay, and then we'll talk about how to read that table next. So go ahead and look at the system call table. In other words, how does your program talk to the operating system? Well, do you think your program needs to talk to the operating system at all?
No.
It needs to know where to find a register. It needs to know how to find a register.
How to find a register?
Like where
It just knows that. It's running in the process.
Okay, what is an operating system? Come on, you guys have used an operating system. What is it? What does it do?
Linux, Windows, DOS.
Okay. It's the start button, right? If I don't see the start button, something is wrong with the operating system.
It's that underlying stuff that makes everything above hardware and below applications work. If you want a more textbook definition from that, I think one of them might have one.
That's a good way to look at it. It's everything that the application relies on, but it is also above the level of hardware. Okay, so it is software, and yet it is not, your application program. And why is there a necessity to use an operating system? What happens when there's no operating system?
everything is in binary.
Everything is in binary. Not exactly. I mean, I can give you a whole bunch of libraries that you can link with your application program, and then you can use all the resources that you can normally use, even compared to with an operating system.
One, your software or your application software needs to know a lot more about the underlying hardware. And two, each application would then be responsible for releasing its own resources, starting itself initially,
and
shutting
conform to the
itself down.
standards too, right?
You'd have no way to switch between programs or start and stop programs.
Well, not
aside
safely.
from just starting
not
them.
safely. Just not safely. We can do it. It's just not safely. I can give you one example. Do you guys still remember DOS, or is that kind of too old for you guys?
We still know DOS.
Okay, you still remember DOS, right?
We all have
So
it running in a virtual
DOS
machine
is
at home.
not exactly multitasking. You cannot run different things at the same time. And yet, it is still an operating system. Okay? In other words, it knows how to create a file. It knows how to create a folder. It knows how to read FAT16 and FAT32 partitions and so on and so forth. So even though it's not a great operating system, it's still providing some services to the application programs. So imagine we take that away. We take DOS away. Okay, there's no DOS. Now, what do you think WordStar has to do? WordStar will have to use your hard drive in a way that WordStar understands. Okay. When you save a Word document, okay, when you save a WordStar document, without an operating system, the application program is now responsible to figure out how am I going to use your 10 megabyte hard drive. Okay, where am I supposed to put in this sector here? Where am I supposed to put a file name and so on and so forth? Okay. So let's just say that the good folks, working for WordStar doesn't have a problem with this. They come up with a really great standard. In fact, it is probably more efficient than DOS. Okay. And then here comes another program called Lotus 123. What is Lotus 123? It's the original spreadsheet program. Actually, that is not entirely correct because the original spreadsheet program is VisiCal, okay, which is a different program. But let's say we're using Lotus 123. And once again, there's no operating system. So when you save a spreadsheet program, the application program has to figure out, okay, how am I supposed to use a 10 megabyte hard drive? Well, I think I have a good way to use the hard drive, so it will save the file using the Lotus 123 standard. Now, what makes you think that WordStar and Lotus 123 understand the file system exactly the same way? There's no guarantee, right? So that means, when you save a file in Lotus 123, you could have corrupted, everything that you saved earlier using WordStar, and vice versa. That would not be good. Okay, and that's why we have an operating system, so that the operating system can provide services based on the bare hardware the same way. Now, when you have a multi-user type of operating system like Linux, it becomes even more important because the operating system also have to help protect one program from another program. Do you guys remember Windows 98, 95? And everything below that?
Please don't remind us of the Dark Ages.
Okay.
We're trying
What
to get
happens?
past that.
What do you experience more crashes, more hard crashes back then compared to Windows XP?
No.
Because you don't use your computer. Okay.
Now, if you compare it to Windows 7, the answer would be yes. We experienced more then, but XP was kind of that high watermark for crashes.
Not if you have Surface Pack 3. Okay.
Oh.
Okay, but
you
anyway,
didn't specify that.
But anyway, the problem is in Windows 3.1. Okay, one application program has full access to the memory space of another program. Okay, in other words, if I am a careless programmer, okay, I can not only trash and crash my own program, but I can trash and crash not only the other application program. I can do something to the operating system itself, and that will land me the blue screen of death. Okay, but Windows NT as a kernel does not do that. Okay, because when you run your application program, the operating system is saying you have this much memory to play with. Oh, I don't like to play by the rules. I want to access location 0. Move $0, 0. Okay, I want to do that just to see what happens. Exactly. The operating system, combined with the ability of the 386 processor protected mode, can say, you are not supposed to touch anything outside of this region. If you do, okay, you get a GPF. You get a general protection fault. The program will crash, but the operating system will not crash because of that. The other application programs will not crash because of that either. So that's why we have operating systems. In this class, we're not going to go that deep into talking about the GUI and all the other stuff, but we do want to understand how do we read a byte from a file that is the default input file, because your homework assignment needs to do that. Okay, so we are just reading one character at a time. That's all we try to do. And it's not really that complicated. It really is not. So we'll go to the portion. Nope, not this one. Where is it? I know it's somewhere. There we go. Okay. So now we have an operating system call table. And let's see if I can find that too. Okay, and a Linux system call table looks like this. Okay, this is the table. Each particular entry has a number that you have to put into EAX. It has a particular name. In one case it's called exit, fork, read, write, open, close, and so on and so forth. And then you also have to, you can also read the other parts here. But the most important part is how we use the registers EBX, ECX, EDX, and ESX, and so on and so forth. So, can someone identify something that we have done already?
In order to exit your program, you put one to EAX and the return value to EBX, and then do something, and define an integer. Exactly.
Okay. If you look at the very first entry, if you put a 1 into EAX and you put your exit code into EBX, and then you tell the operating system, this is what I want to do, the operating system will interpret as, oh, this program is ready to exit with whatever code or whatever number is in EBX. So that's how you request the operating system to do something. You load certain values into a register to specify which surface you want to use, and then you use the other registers to supply additional information, and then the magical instruction after all this stuff is the int $0x80. It's called a software interrupt. We'll talk about the software interrupt later on, but at this point we'll just say this is the magical instruction that tells the operating system, I need some help. Okay? And what you need help with is specified by EAX and some other registers depending on what you're doing. Just reading this table here, can anyone identify which one you will actually need in order to do your homework assignment?
cisp310.
It will be cisread. Okay? Cisread is what you need in order to do your homework assignment. So what that means is you have to load a value of 3, a constant of 3, into EAX first, and then what you need is to supply something in EBX, something in ECX, and something in EDX. Now, if you have read something like this before, okay, or if you know what these types are for, you can probably already know or get or imply what they are for. Char pointer. What do you think the char pointer is for?
That's where it takes the data and puts the data you read.
Exactly. You're reading some content from a file into a portion of memory. So ECX is a pointer to point to the region of memory where you want to read it into. What about size T? What do you think size T is going to specify?
The number of things you're reading.
The number of bytes that you're reading. You're reading in number of bytes. So that leaves one thing remaining, which is our EBX. What do you think EBX is going to do?
That's going to be which file handle we want to read from?
Exactly, because at this point we have not specified which file we want to read from, so we have to specify which file we want to read from using EBX. But hold on a second here, Tech. That means the file name can only be up to 4 characters. Because EBX has 4 bytes and 1 byte for one ASCII character. That means I can only deal with a file with 4 characters.
It's an
That's not
integer
true.
File handle,
Exactly.
not the file name tag.
Exactly. It is a file handle. Okay. Now you should not have any exposure to the concept of a file handle in your cisp360 class. But basically, internal to the operating system, every file is represented by a handle. Basically, it's a 32-bit number. Okay. When your program first starts execution, the operating system pre-opens 3 files for you to play with. So you don't have to do a single thing to open those files. They are always opened, and they always have specific numbers associated with them. File number 0 is the input file. That's a standard input file. Whatever you type on the keyboard is file number 0. File number 1 is standard out. Okay, when you go to your when you use a C class or C++ class, in your C++ class, whenever you use C out, it corresponds to file handle 1. Whenever you use CR, it is file handle 2. So C in is file handle 0, file out, the C out is file handle 1, and CR is file handle 2. Okay? And that's how you read from a file. Now, yep, go ahead.
I got a question then. What's C log?
C log?
Yeah. It's another one that comes standard. C in, C out, CR, C log.
I would imagine that would be file handle number 3.
Okay.
But basically, whatever you write to that, will go to the syslog D daemon, and then the daemon will have to decide what to do with that string. The normal behavior is just to add an entry to the syslog itself, so your log will be intermixed with the log from all other programs. But that behavior can change too, depending on how it's configured. Okay, so let's go ahead and give it a try. Let's write a very simple program to test all these concepts to make sure that our understanding of these concepts is correct. In other words, let's give it a try and read not just 1 byte. Let's try to read 4 bytes at once and see what happens. So the file name describes what it is about to do. whenever you're reading something, you have to read into the dot data section because it will change those 4 bytes. So over here we'll say buffer, okay? It's just a label name, and after this we'll allocate 32 bytes. Then we switch back to the text section to define our program. First of all, we have to export the special labels start, and then we define start here. And the few things we have to do, the first thing we want to do is to initialize EAX to request a read operation. So if I forget what it is, I can always go to that particular section here, system call table, and read is using 3 as the number. So we go back to our code and say move 3 into EAX, and I will put a comment here, okay, requesting a read operation. Can someone remind me what EBX is about? I actually know, I just want you guys to, the file number. So in this case, if I want to read from standard in, which number should I use? 0. Into EBX, read from standard in, cin. What about ECX? What do we use ECX for? Where in memory do we want to read those bytes into? So in this case, we'll read it into buffer. So that's in ECX, where to read the characters into. In other words, that's the destination, okay? And then we have one more EDX to specify. What do we put into EDX? Number of bytes that we try to read. Okay, it doesn't mean that we can always read that many bytes, but we'll try to read that many bytes anyway. Okay, so we'll say in this case we have 32 bytes allocated, so we can potentially say try to read 32 bytes. So we'll go ahead and do that. EDX. How many bytes should we try to read? Because a file may not have 32 bytes. I can give this thing a file that only has 1 byte or even 0 bytes. Okay, so I may not even read all the bytes that we are supposed to read. Then we have the int $0x80. Okay, ask the OS to do it now. Okay. And after this, we'll go ahead. I think we need a no op here in order to put a breakpoint next to it. So we have our usual checkpoint, and then we have $1 to EAX, 0 into EBX, and another int 0x80. Yep.
Can you move that no op past the checkpoint so we can use it? Yeah.
Think so?
Yeah.
We can use it the other way too.
It won't break on the no op though, it'll break on the end.
No, it'll break on the no op.
The whole idea is I don't want to break on the no op because you cannot put a breakpoint right after the software interrupt. So it's a spacer just to space it out so that we can actually put a breakpoint at checkpoint. Okay. All right, so let's go ahead and run this program by hand first, and then we'll run it using a redirect method because we want to consistently use the same test file to do something like this. We have as read4 bytes.o, read4 bytes.s, ld, read4 bytes, 4 bytes.o, gdd, read4 bytes. Put the breakpoint at checkpoint, and we'll go ahead and run the program. And someone will say, uh-oh, tactical program is now hanging. It's not doing anything. Well, it's not exactly hanging. It's actually running the program. The program is saying, I want to read from the keyboard. So it's waiting for me to type something. Okay, so I'll type something here. Okay, this is a line. Press the enter key, and then it stops. Now, it stops only because when you type something interactively, the input is what we call cooked. Okay, cooked means the enter key or ASCII code number 13 actually has a special meaning. Okay, it says okay, stop here. Let the program continue to execute at this point, and so the line break character has special meanings. Okay, so there are several things we want to check at this point. First of all, we want to check what is in buffer, right? Because after all, we are supposed to, put all those characters that I just typed into buffer. So which debugger command do we use to check that? Examine, which is X. So we can go ahead and examine all 32 locations if we want to. And each one is a character, C for 1 byte. And we want to display it as, okay, I cannot remember. Let's see, we want to examine, each one is a character. And it is a
still
byte. It's a B. Okay.
So 32
X, B, C. Starting at buffer. And this is what we have read. Okay, we have T, H, I, S, this, and then a space. I, S is, and then another space, A, space, L, I, N, E. We got something that's kind of interesting here. What is \n? It's a new line character. That's because I pressed the enter key. Okay? The next question is, looking at this, I don't know exactly the number of characters that has been read. Okay? You can kind of see that everything else are zeros, but that's only because they were initialized to 0. Okay? Which is not a reliable way to tell whether I have actually read 32 bytes or 16 bytes or whatnot. As it turns out, EAX serves a purpose in this case. Because when you use the $0x80 for a file read operation, when it comes back to your program, EAX indicates the actual number of bytes read. Okay? Well, we can double check and see whether that's the case. It tells me that it has read 15 characters. Is that right? Let's do some counting here. Let's see, where did I type? Right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Tag, you're wrong. Exactly. The new line is counted as 1 character as well. So the program actually correctly read exactly 15 characters. And EAX tells me that it has read 15 characters. Okay, so great. This is working just fine. But can I test it with a file that has 0 bytes? I cannot do it using the keyboard, because the moment I press the enter key, even on an empty line, it would have read the line feed character, which is 1 byte. Yep.
Can you put a Control D?
Control D. Well, let's go ahead and try it. Okay,
Wouldn't it terminate the whole program?
I don't know. Okay, let's go ahead and do it. Control D. Let's come back here. So it does not terminate GDB itself. Sometimes it gets confused. Okay. So now we can check EAX again, and EAX says there's no byte, because it is end of file immediately, and it reports in that it has not seen any bytes. Okay, so this is how you check for end of file. When EAX has a value of 0 after you request to read more than at least 1 byte, and it comes back and said, I didn't read anything, that means it has encountered end of file and it's time to get out of the loop. Is that okay so far? Now, your program doesn't read 32 bytes at once. It only has to read 1 byte at a time. Yep?
What if you're filling up a buffer there? How do you know that you got to end of file, not end of line, if you have 15 bytes read in?
You have to read again. So if you read and it reports back, it has read at least 1 byte, then you have to attempt to read again to see if you are now encountering end of file. So you basically have to keep in that loop until a particular read operation reports it has not read anything, then it's time to get out. Okay, so the next thing we want to do is to say, well, this is all nice and fine, but in order to test whether my program is counting the number of spaces, I don't want to have to type something and count 1 space, 2 space, 3 spaces, and so on. I want to create a test file so that I can feed the same test file to the program every single time, so this way I don't have to retype anything for testing. And there's a quick and easy way to do that too. So the first thing you want to do is to create a test file. So in this case, I can just put in something that's simple in my test file. Okay, 1, 2, 3, A, B, C, and all 5. Okay, that's the content of my file. And then I can use GDB to run the program, kind of as usual, like that. Put a breakpoint at the checkpoint, just like usual. Except this time when I run the program, I specify redirect input from a file. In this case, the test file is test.txt. The less than symbol is called the redirection symbol or operator. What it is saying is run the program, except the standard in is no longer the keyboard. I don't have to type anything. Take everything from test.txt, which is the file that I created earlier, as the input to the program itself. It is not the input to GDB, so now it is separating the input to GDB completely from the input to the program that we are debugging, which is the great way to do it, because this way there's no confusion anymore. So I run the program, it gets to the checkpoint because at some point it has to end, and I can check the number of characters actually read. It reports 20 characters. I can look at the 32 bytes, or this time I know exactly 20 bytes to look at, BC at buffer, and those are the bytes that I've read. I only have to check the last one, and of file. Okay, so we have the F, I, L, E, and a final line feed over here. So the program is working just fine. Okay, it reports in the correct number of bytes actually read, and it terminates because it is not a loop anyway, so it always terminates in this case. Yep.
What if you try to read more than 32 bytes?
Good question. It will just report in that it has read 32 bytes, and some portions would not be read at all because I only attempted to read 32 bytes. Now we can definitely try that. Oh, I don't have to leave the program at all. I can rerun the program, except this time I will send it a file that has more than 32 bytes. We can send it the source file of this program. Why not? Right? So we can say read 4 bytes dot s. Okay, and run from the beginning. Take a look at EAX. It reports that we have read exactly 32 bytes because I said read up to 32 bytes. If the file does have at least 32 bytes, it will read all those 32 bytes. The next read operation, if I had one, will begin with the 33rd byte of the file. Okay, in other words, the read operation is sequential. It keeps track of its own file pointer, so it remembers the last character it has read. The next read operation will pick up from there and will automatically go on. There's no need for you to advance the file pointer. It's just like with cin, you don't have to rewind the pointer or point it to the future. It just continuously reads whatever is in the input stream. Yep.
So we're going to need to use these registers to read data in, right?
Read.
To
What
read our
register?
character, we have to use registers EAX, EBX.
Yes.
Is there some way that we can store the values that are in there and
Yes, but we
reuse
haven't
the
talked
registers
about it.
later? Could
Yes.
you talk about that? Because that would be really useful.
Well, you have count anyway. I mean, count is in memory, and you
It's
can use
only in
but you
memory.
can use one single instruction to increment something in memory. The restriction is you cannot have two memory operands. You can have one memory operand and one immediate operand.
I think we're talking about different points.
I think we're talking about the same thing. If you want to optimize the program so it doesn't access memory unnecessarily, then you are right. Okay? But if you use push, it is still memory access, so you're not saving anything at all. Okay? Any other questions? Yep.
How do you be able to exit the loop? Because I know when you're going to be jumping back up.
Okay. Let's take a look at the assignment. Where is it? Okay, I may not have it open. Let's go ahead and take a look at the homework assignment. Oh, it's one of these tabs here. Okay, it will exit the loop because at some point it will not read a character. When you're at the end of the file, you try to read a character, it will come back and say, I did not read anything because there's nothing else to read. So you have to use that logic to get out of the loop. Okay? I can replicate the condition using just this part here. Okay? And you can probably do the same thing here. If you use the touch command, you can create an empty file. So I can create an empty file called empty.txt. I can double check to make sure it is empty by using ls, ls says exactly that it has 0 bytes. This is an empty file. So when I run gdb, set up a breakpoint, b checkpoint, I can now run it and redirect the input so that it comes from empty.txt, which is an empty file. So it will encounter end of file right away. Okay, I run it, I take a look at EAX, it reports it has not read anything because there's nothing in the file to read. This is what you see when you encounter end of file. Did I answer your question?
I was just saying, like, how the \n, is that the end?
No, \n is not the end. \n, as far as your program is concerned, is nothing more than another character that is not a space. Because you only care about spaces. When you see a space, you bump up the counter. If you see anything else, don't mess with the counter. Just leave it the same as before. Is that okay?
Was it still stuck inside of it?
No, it won't stuck in the loop because every time you read, it will get closer, one character code closer to the end of file. So if you read enough times, it will get to the end of file. Okay? Unless you redirect from /dev/0, then it will never end.
Or /dev/urandom or.
Yep. Are we good on this one? Yep.
So if backslash n is entered, keep reading the
Could you speak up a little bit? Sorry.
if backslash n is entered, keep reading.
Keep reading. You keep reading until there's nothing else to read. But whatever you read, it only matters if you're reading a space character. If you don't read a space character, just pause it away and then keep reading. Yep.
Are we required to only read one character at a time, or can we read more than one if we want, as long as
If
we
you
get
want
the
to
right
read
count?
multiple bytes at a time, knock yourself out, okay? But the logic is simpler when you read only one byte at a time.
So as long as we get the right count at the end and
Yep.
have used the same basic methods.
Okay, but do not allocate any more than 64K, okay?
I can't allocate the 8 gigs of RAM that I have and expect you to be able to test it.
Then I have to write another program to type the output into yours and make it 8 billion plus 1 byte of the space character. Yes, there is such a concept called pipe, man.
It's the cat you're smoking right there.
Pipe is good.